A software engineer specializing in data science, is pioneering token engineering as a service at MVP Workshop. Designed and implemented complex crypto-economic models for various high-profile projects, possesses deep understanding for both finance and blockchain, and he's going to talk about token engineering.
Dope. Hope you can hear me. I'm glad that no, there's not much people that are leaving right now, so that's good. I feel like this panel before me was like a good introduction to the talk that I'm going to be giving. So I'm going to be talking about token engineering. It sounds kind of weird, but it's actually quite a niche field, but it's attracted a lot of high quality workers and like high quality researchers. And we try to do good to the whole Web3 ecosystem, not just for the prices, but also to create products that are well designed and worthy of everyone's time and money. So the talk is called Token Engineering, unveiling the toolkit and practical insights. That means I'm going to be talking about more practical stuff. So let's start. So a little bit about me. I'm the MCF alumni. I think people that are coming to Cryptic are very well aware. So I come from finance. I have a finance background. I worked in Web3 R&D, focused on DeFi and mechanism design. What does that mean? That means that if you heard about AMMs, yield farming, all of those complex mechanisms, I probably worked on them already. I was also a teacher in Token Engineering Academy for a couple of months, for around half a year, where I was teaching users to actually design these crypto economic systems, how to tackle these problems, etc., etc. I'm also a pioneer of token engineering as a service MVP workshop. Before I joined, we haven't done this service at all. And so far this year, we worked on auditing of blockchains that are worth around 300 million and 400 million market cap. And also we worked on creating tokenomics and business models for like larger enterprises, one of which is like one of the largest enterprises in Asia that's in automotive industry. And I'm also a very big fan of free and open source software. I try to like contribute in any way I can because I think the open source will save the world. So let's start with the actual agenda. So I'm going to be talking about what is token engineering, what's the importance of business modeling, because at the end of the day we are talking about businesses. I'm going to talk about how the average token engineering project looks. I'm going to talk about parameter selection under uncertainty, which is just a fancy way of saying what to do when there's no data to create models based on. And I'm also going to be talking about what we do when we do tokenomics auditing and what metrics are we looking at when we do the audit of the tokenomics of the project. And of course, a short conclusion and a short message for all of you guys. So what is token engineering exactly? If you look at tokenomics, like people are always thinking about the prices of tokens, blah, 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 we're investing, etc. But we're actually dealing with complex dynamic systems. What does that mean? That means that blockchains, if they are somewhat decentralized, they have a certain degree of complexity. And how do we achieve this like decentralization and complexity is by including the tokens. So there's an interesting quote by Trent McConaughey. He was like, he's a founder of the Ocean Protocol, which is a decentralized AI platform, which says that blockchains are incentive machines with the power to get people to do stuff with tokens. And of course, it draws from systems, engineering practices, economics, AI, behavioral economics, etc. If you look at this flower, we can see that it encompasses quite a lot of fields. What does that mean? That means that even though like the economics are set correctly, we have a perfectly designed mechanism, we may have some technical boundaries. What does that mean? That means, for example, the blockchain we're building on cannot use a root in a function or whatever, and that basically destroys the whole idea. So we have to know a lot about philosophy, ethics. We have to like know the technical boundaries we're working in, etc. For example, like also the project can be perfect in theory, but if you like, if there's some ethics problems, if it's malicious, nobody will use it, and you will face scrutiny. So this is just some of the protocols that faced economy exploits. The values lost is like in billions of dollars. It's not well designed, but I think does it showcases the point correctly. Just one of these fields, one of these companies, one of these products costed users around $80 billion lost. And if we continue using the old approach, we are basically being this guy that's just having like a hole in his hands. And we're basically designing the same malicious projects with mistakes as before. So just one of them, like Terra, I think costed users like 80 billion. And let's continue. So I think most of you guys are from have a business background in some way. So I'm not going to waste a lot of time showcasing this, but the main idea is to look at the company as a dynamic system. What does that mean? If we follow the works of Jay Forrester, which was he was like a dynamic systems researcher, he has a philosophy that states and companies should be looked at as dynamical systems. So if you have a company requires some resources, they issue stock. When they issue stock, they use these resources to employ workers. They create extra value, and as a consequence of that and a good product, the company stock will grow, in theory. That's why I said simplified. And of course, when they work, they create revenue. Revenue can be further invested into the product, and then, or even they can pay dividends or do buybacks or whatever. So this is the basic company example, for example. And now we're going to talk about Web3 companies. What does that mean? These are not the companies. Slides, they're basically the same. But the payments and everything, a majority of payments is handled through the tokens. What does that mean? That means that the company, the protocol, will get its funding through the emission of the tokens and distribution of the tokens. That means that we, as protocol designers, as designers of these economies, like Ethereum, like Polkadot, or whatever, we need to think about how do we allocate these tokens, these pseudo stocks or shares, how do we allocate them in a way that when we pay the workers, like the open source contributors, and we pay the grants with those tokens, we don't damage our price on the market. So essentially, it's the same logic. So we generate some tokens, we get some investors through the ICO, etc. We dedicate some of the portion of the funds to the team and the governance, and then we invest. We choose what grants, what workers are the most optimal for our project. What does that even mean? So, for example, financing, like giving out tens of thousands of tokens for some lecture that is on a faculty of, I don't know, social sciences, is not going to yield the same benefits as investing in the real projects that bring more value to our product. So essentially the same, the sustainability loop is the same. Just like when we get revenue, we have an option to either buy back and burn the token, or we can reinvest it and allocate the tokens elsewhere. So I talked tried to give a little bit of context, but if you look, there's a lot of letters here, but this is how the average token engineering project works. So if you guys ever wondered how do we actually design the tokens that we are talking about, that we are talking on the crypto analytics panel, how do we actually design these tokens? So it usually starts with the ideation workshops where you have a founder that has a vision, and then we try, and me and my team of mathematicians, we try and work with them to actually see if this product is viable from the business side. And of course, there's also, well, if we get the initial inputs, then we see if the idea is good, there's a high probability that somebody already built this. What does that mean? That means that we have to do benchmarking. We do it quite quickly. We do it in 2 weeks or something. After we do that, we see, okay, these projects failed for some reason. Let's try and not do that. Then we try and design the initial mechanism. These are the rough designs. Then we try and formalize everything through the mathematical specification. What does that mean? That means that all the internal, external factors, parameters, variables, influences are written in a mathematical specification. Because then we can use the specification to actually model the system and model the scenarios. What do we do then? Then we do simulations, iterations, 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 and most of the work is basically iterating on the model to try and find the most optimal combination. Of course, once we get to that, we get the final mechanism that's proposed to the founders. They say, okay, this works, let's do it. Then we go to of course, the harder part, which is actual deployment of these systems. And you get, for example, you have to build smart contracts, which don't allow you, for example, to use the roots. And then we have to go back to the drawing board and iterate again. So once we do this, the project is ready to go and it's deployment time. So what does that mean? Once the project is deployed, it's basically live on the network or either a test network or it's live on mainnet, then we do the maintenance. Why is this good? Because before we launch, we have no data. When we launch, we get some initial data. We see that some part of the project is sticky, some part of the project is not. And then we use the real data and iterate again and see if we can make some quick changes. What are the hardships? When we launch a new token, nobody really wants to list it, usually, unless there's significant investor backing. There's some market making costs, hardships, where to launch, what exchange. Do we do decentralized exchanges? Do we do airdrops? Do we do liquidity mining, etc.? And of course, there's no data, so we use a bunch of assumptions which might prove completely incorrect. And we might design something that's worth nothing. And of course, when you're dealing with small teams in Web3 space, especially lately, it can be quite slow and quite expensive for the founders. And they're like, okay, I'm not gonna pay a certain amount for a team of mathematicians to validate something. I'll rather just ship something and pray for the best. And of course, it requires a lot of participation from the client and founders, which is a problem as well, can be a problem as well, because usually founders are not that deep into mathematics and complex system stuff. So it requires a lot of arguing and a lot of just going back and forth and wasting time. So I'm going to talk, this was how to do a design. And now what the bigger problem right now, especially lately, is how to do the audit of the tokenomics. We have a lot of approaches where the people are just auditing tokenomics, just looking at the use case, saying, okay, we know a little bit of game theory, this will work, this will not, but this doesn't cut it, especially for big projects. We need data. So we're also doing the standard stuff, ideation, brainstorming sessions, benchmarking, but we also have the more important part, which is the gathering the on-chain data. That means that blockchains are data mines, and we have a very big amount of data that we can work with. What does that mean? That means that if you have a block that's generated every 12 seconds, you can have a bunch of blocks and a bunch of data that you can work with. And of course, when you have data, it's quite easier to model changes and to see how the change of certain parameter will influence the system. And of course, we're doing the regular stuff, which is regular meetings, simulation, iteration, the new mechanism design, smart contracts and testing. Usually something is off in the practical sense, so we iterate again. And of course, the maintenance is the same. Basically, once we propose new changes, change the tokenomics, we have to maintain the system and see if our changes are working as intended. So what are the hardships? Usually there's a lot of data to fetch and analyze, especially because we are fetching both the on-chain data and the market data. So just the process of fetching this and making the sense of this all of this data can be quite a burden for the team. And of course, there are bigger risks. Once you have a chain live, like Ethereum or whatever, you have a bunch of users that are already using this chain. And they are not really ready for you to just come in and scale the fees 100 times. And that means that we have to be very careful, because if we play around a lot, we're going to kill a whole ecosystem inside of an ecosystem. If you have DeFi, if you have scale fees or add some additional parameters, you'll probably destroy that field, and people are just going to spam a lot of like hate on Twitter for your team. So how it work? How does it like work usually? I just drew like a quick graph as an example. Like the goal of the fee is like 0.5 for an average transaction. We could in theory scale the fees, but you cannot just do it right away because you would kill the whole ecosystem. So you have to scale the fees like in a slow manner. That way the users can and the projects can change their code, like do the testing and accommodate the new fee structure of this blockchain. That means this is just an example from, it's not the exact replica, but it does the same thing. We did it on some Polkadot parachain, where we had different virtual machines with completely different fee calculation, with completely different system of working, and we needed to like make them equal for like 90% of the transactions. And it took us, I think, just the alignment of these fees for like an average fee on different virtual machines can be a project in itself. So I think that's quite important to showcase because this kind of work is not that easy as it seems. So what tooling is used usually? The tooling used is like initially we have a bunch of like non-technical people participating, which is a bunch of tokenomics canvases where you map the users, map the agents in the system. We use like a lot of system stakeholder mappings, competitor tables, because we don't want to waste time people writing like bunch of, we don't want to have content that is written by researchers that is not directly benefiting the end goal. So we don't want the users, the researchers that work with us, we don't want them writing like 30 pages of junk. We just want a table with like parameters, with values, with reasons why it's not working, etc. And of course, there's like causal loop diagrams, which is used in system modeling. I'm not a big fan of those, especially when you're dealing with complex systems with like 500 parameters, like 1,000 variables. It just sucks. And of course, stock and flow diagrams. These are like you cannot see them because of NDA. I cannot just zoom in because I'm not allowed to do that. So it's like a bunch of like those lines and boxes, etc. And lots of meetings with the founders. So I think the most interesting part for you guys is the design and validation phase, because this is a data science conference after all. So we do a bunch of mathematics. What does that mean? We do a lot of like equations, differential equations, stochastics modeling, etc. And of course, we sometimes use Excel, which I'm not a big fan of. But if you like have to do something really quickly to validate something, some idea, we can do it in Excel like 5 times faster than in Python. So we use Excel, but only if, like as a last resort. Of course, we use Python, and these three tools that I will talk a little bit more in the next slide. So why do we use these tools, which are also open source, by the way? It's because we can do like with these models that are quite huge, quite big, we can do quite a lot of like quite a lot of stuff, and that's why I'm talking on the data science conference. It's basically we use the CAD and RADCAD, which support like Monte Carlo simulations, A/B testings, where you have one model and you have another, and then you see which one's better. You have parameter sweeps, where you run like 1,000 combinations of parameters to see what is the most optimal one. And we do also agent-based modeling, where we generate some agents that interact in an intelligent way or a semi-intelligent way with our project. And of course, once you do this, like when you do like the basic modeling stuff, it can easily be integrated in the other data science workflow. There's also token spice. I'm not a big fan of that. It's because it's optimized for a certain product. And there's also machinations. Before this talk, I talked with the founder, and he told me that they are using machinations. My opinion is that it's a great tool, but we haven't used it since our models are quite bigger. So I told you that I'm going to talk about parameter selection under uncertainty. That means how do we configure these complex systems when there's no sufficient information? The idea is to see how we can set the values of these parameters when we are designing. So if you look at this picture, you can see that there's a bunch of system goals, but some of the control parameters may be beneficial for one goal, but they suck for a completely other goal, and they're destroying the system. So we're like trying to firstly choose like the optimal system goals to like attach quantitative measure to qualitative goals. Even though it sounds like paradoxical, we try to see, okay, if our goal is to be profitable as a protocol, we say, okay, how profitable? We want to have 100 developers. Okay, how many, like, we want to have a lot of developers. Okay, 100, for example, how much is this going to cost us? Let's try and model all of that. And how we are going to pay them, and how we can ensure that our token is not damaged by like paying all of these people. And of course, we're trying to like choose the control parameters. What does that mean? That means that we are setting parameters that are dynamic based on some certain conditions. And of course, we have the environmental parameter identification. That means when we are not building in a sandbox, like tokenomics and Web3 is like a massive multiplayer game where like 20% of the players are just gamblers and are just like behaving irrationally. So we have to try and model that based on real data as much as we can. That means modeling the price of the chain that we are building on, or the chains that are direct competitors or whatever. And of course, we have to like define the metrics that we're going to track. That means if we're tracking the liquidity or whatever, we have to like specifically have a variable that's tracking all of these stuff. And of course, to define the simulations, scenarios, like if we have no data, we're like generating the data either based on previous data, or are we just like generating like stochastic processes or whatever, like Poisson process, etc. And of course, like when you see this is often a question in my company, is like, okay, are we just like choosing the parameters that we like or whatever that make the most sense? This is not really the case. At least we try not to. So how do you decide what's the optimal parameter? Optimal parameter combination for the project that is decentralized is basically you run 1,000,000 times the simulation, and then you check, okay, this combination of parameters are guiding us into this pit of despair, and we try to remove all of the parameter combinations that are actually like leading us to these kind of states. So this is not the best picture, but this is essentially what we do. So yeah, and of course, like to finish, what metrics are we just checking when we're like doing auditing of tokenomics? Is we're checking price movement, volatility, volume on the exchanges, vesting schedules, validator economy, usage of the network. You cannot only just look at the price and then just like have some pseudo takeaways from that. Fee structure, users elasticity, what does that mean? That means if you have a bunch of players, like a bunch of wallets, like doing a bunch of small transactions, you cannot just scale the fees tenfold. Governance structure, tokenomics mechanisms, where the staking and other rewards come from. If you don't know where the staking rewards come from or yield, you are the yield, and basically this is a one big Ponzi scheme. Treasury expenditures, like where the tokens are spent on, revenue, expenses, etc. And those also, like when a company comes to us, they usually have some problems that we cannot find that easily. So to finish this, because we don't have much time, the conclusion, tokens are a superpower for funding open source project. What does that mean? That means that if me and my friends here have an idea of a project and we need funding, we could essentially launch a token completely anonymously. We could be anonymous, and maybe we could get some funding regardless of are we like registered or not. We need to focus on economic security. Why is that? We need to focus on token engineering, especially because we cannot design the tokens that people are going to invest and then lose their life savings on. And of course, since this is a data science conference, blockchains are data mines. We can easily use this data to make informed decisions. And of course, tokenomics is not just a pie chart or like a consulting thing. It's mostly like a data science thing, and of course, like there's some business modeling as well. And let's try all of us and be less like the guy on the picture, which is the Ponzi guy. And I think our mission is going to be, we're going to like create a lot of benefit for the Web3 ecosystem. So this is it from my side. Thank you. And yeah, that's pretty much it. I guess now it's time for questions if we have time left. So we have 2 minutes, so. Thank you.
So I was proud to listen to you today, and then the next speaker will be also from the MCF program. So that's really a pleasure
Thank you.
to have that. Okay, thanks.